Hello everyone and welcome. In this video, we're going to be looking at A-star search. The A-star search is one of the shortest path algorithm, which is used in finding the shortest path between two nodes, a source node and a destination node. Now, the A-star search is a more efficient search than the Dijkstra's algorithm. And one of the key reasons why this is the fact that there is no need to explore all of the nodes in the A-star search. It makes use of the heuristics, and heuristics is the estimated distance between the node, a node we're exploring, and the end node, so our destination node. Now, for the A-star search to work correctly, we need the heuristics to be admissible. And this means that we should never overestimate the value of the heuristics. Let's look at an example. In this example here, what I've done here is, you can see here we have our graph. And we want to look for the distance, the shortest path between A and F. You can see all the nodes we have here, A, B, C, D, E, F. These are all the possible node routes we can take to get to F. On the right hand side, you would see the table that shows the heuristics for each of the nodes we've got. Now, don't forget that what this value is showing us is the distance between each node to our destination node, which is F. So looking at this, I know that my estimated distance from A to F is 63. The estimated distance from B to F is 44. And you can see this is 0. So the estimated distance from F to itself, it's 0. To solve this problem, I have created a table here. Now, what this table indicates are the nodes. So we can see our nodes A, B, C, D, E, F, all listed down here. And the values corresponding to, the heuristic values corresponding to each node. The first thing I'm going to do is to explore my source node there, which is A. So I'll just write down A here. So A to A, we know it's 0. Okay, so A to A, I know it's 0. Now 0 plus 63 gives me 63. So the best known node to A really is currently weighted at 63. The same thing applies to B. So I'll move on to B. A to B. A to B is 12. So I know it's 12. 12 plus 44 will give me 56. And that's coming from A. And I'll carry on that way. A to C doesn't quite exist. So I'll put infinity sign there. A to D is 22. So I know it's 22. 22 here plus 70 will give me 92. So I'll write down my 92 there. And that's coming from A. A to E doesn't exist. I'll put my infinity symbol there. A to F there doesn't exist. At this point, I can say that I have explored all of A. The next thing I'm going to look at there is the node with the shortest weight there. And currently that's 56. 56 is smaller than 92. So I'm going to explore B next. So I do know that with regards to the normal path from A to B, it's 12, okay? But when I consider the heuristic value, it's 56 coming from A. Now that 12 there, I'm just going to say B12, because 12 is the value I need to consider whilst working with the graph here. So we've explored all of A. I'm now going to look at B to C. Now, B to C is currently 11. I'm going to say that 11 there plus my 12 there will give me 23. So 23 plus 40 will give me 63. And that's coming now from B. Now, B to D doesn't exist, so the best known path that I have is still 22, and considering the heuristics, that's 92. B to E doesn't exist, so I'll still bring down my instant infinity symbol there. B to F actually exists, and that's 59. So I'm going to say 59 plus 12, which is the 12 I've written down there. 59 plus 12 will give me 71. 71. Now 71 plus 0 is 71. And that's coming from B. At this point, I can say that I have explored all of B. I look down here again, and I'm looking for the node with the shortest weight, with the smallest weight, and that's currently 63. It's smaller than 92 and smaller than 71. So I'm going to explore 63 next. Sorry, I'm going to explore C next. And C has the best known direct weight with using our map alone to C is 12 plus 11 there, which we have as 23. So I'll just put down 23 there. Okay. So 23. So C to D is 16. 16 plus 23 gives me 36. And 36 plus 70 gives me 106. Now, I can see there, you can see there that 106 is larger than our 92 there, which means there is no need to write 106 there, because the smallest weight, the shortest path currently to D is still from A. So I'll just represent 22, 92 there. Now C to E is 15. 15 plus 23 here will give me 38. So I'll write down the 38 there. Now 38 plus 23 gives me 71. Sorry, gives me 61. I'll put the 61 there. And that's coming from C. C to F doesn't exist, so the best known path currently to F is still 71, coming from B. At this point, I have explored all of C. I'll look down here again. The next node I have to explore now is 61, which is E. So because I'm looking at the weights here, and 61 is the shortest, and that smallest weight there is for E. So I'll just come down here, say 38, 61. Okay. And I'll write there E, which currently has the shortest path using our map of 38. So E to D doesn't currently exist. So as E to D does not exist, I'll write down the current best node there to D, which is 22. However, considering the heuristics is 92, and it's coming from A. Now, E to F there is 27. 27 plus 38 gives us 65. And 65 plus 0, which is the value of our heuristics there, is 65. And that's to E. That's coming from E. Now, at this point, the smallest node remaining for me to explore is actually 65, because I've explored all of E. The shortest node now is 65 here, and I will stop. Because I'm at the point where I'm now exploring F, I'll stop in an A-star search. I'll just stop there. I don't need to explore all of the nodes. So, looking at the best path now from A to F, I'll go to my destination node there, which is F. So if I write down F there, F, what's the node underneath it is E. I'll put E there. Okay, I'll go to E. The node, last node explored there, best known node to it is C. And I'll go to C. Best known node to it is B. And I'll go to B. Best known node to it is A. So the shortest path between A to F is A, B, C, E, F. And the weight is 65. The weight is 65. So this is the shortest path, and that's the weight.